Hello, Algebra 2. Tonight's topic is 8.4, Logarithms, Day 4. And our essential question tonight is, how can I use my knowledge of logarithms and exponential equations to now solve equations? So let's first review some solving equations, in particular with exponents. In this first question we have here, x to the third power is equal to 8. And remember, when we're solving for our variable, we are just trying to figure out how we can isolate this x and find out what that answer might be. So in this case, our x is pretty well isolated except for the exponent. And remember, the way we would solve for this problem, now that the x to the third is isolated, is to just take the cube root of both items, because that would cancel out the cube. So x to the third power, to solve for that, we would take the cube root of both sides, because whatever you do to one side, you have to do to the other. So x to the third, remember the cube root is 1/3, and that allows this power to cancel, because 3 times 1/3 is 1, so that would be x. And then the cube root of 8, remember, is 2. We always would check our answers after we solve, and we're going to plug in 2 for x, so 2 cubed, and that does equal 8, so we solved that correctly. Alright, now if we had an equation where the exponent is the variable, that's what we call an exponential equation. That's an equation where the variable is the exponent. So if we had this example, 3 to the x equals 81, remember we could solve it by thinking about what power, 3 to what power would be equal to 81. And we know 81 is 3 times 27. And we know 27 is one of our perfect cubes. So that would be 3 to the x equal 3 times 3 to the third power. So since we're multiplying the same base, that would be adding these exponents. So that would be equal to 3 to the fourth. So anytime we have the same base and it's an equivalent statement, our exponents would have to be equal. So our x would be equal to 4. And we can check that. 3 to the fourth power means 3 times 3 times 3 times 3. And if we check that, that is equal to 81. So this one's not too hard with our knowledge of fourth roots, because we know a lot about our perfect cubes, but we have another way to solve them if it's not a perfect fourth root or cube root or square root, and that is with logarithmics. And we've been talking about these functions, but we haven't talked about their relationship with exponential. We've said the graphs are inverses, and that's true, as is the equation. So these are equivalent statement. 3 to the x power is equal to 81 is an equivalent statement to log base 3 of 81 equals x. And notice that this base is the same, log base 3, and here our base 3 is to the x. So that's where you're going to start when you're converting between the two. The other thing to realize is this is always your power of your exponential. Okay? And the way you read this equation is log base 3 of 81, whatever's here, is equal to x. And again, that's the power from this equation. And again, the inverse of the exponential equation is called a logarithmic equation. And this allows us to solve, we can convert between the two to solve different problems. And the logarithmic equation means, particularly the one we were looking at, is 3 to what power is equal to 81. All right, so the first step before we start solving is just practice this conversion from exponential to logarithmic notation. And the way you start when you convert from exponential to log is to realize what the base is. The base for this exponential is 4. And the first thing you always write down when you convert from exponential to log is log. So log, and then you write down the base of the exponential, so it was 4, and that's always written as a subscript, so it should look small and lower than your g here for log. So log base 4, and then the of is what is on this side of the equal sign for the exponential, and then it's equal to the power. In this case, our x is our power. All right, let's try the next one. So again, the first step when we convert from exponential to log is to write log, and now the base of our base is 1/2, and then of 32 is equal to our power of -5. All right, I want you to go ahead and pause the video and try 3 on your own and bring it back. All right, you should have log base 7 of 343 is equal to our exponent of a plus 2. All right, now we're going to try in the reverse. Convert from the log to the exponential. So when we're converting from log to exponential, the first thing is you lose the log, and then you write the base. So our first step is we're going to write the base of 7. Now we write the exponent, 2, equals the of part, which is 49. So base 7 squared is equal to 49. For our second one, again, we're going to lose the log and write the base of 2. And then the x is the power, and then equal to 64. Our third one, I want you to try on your own and bring it back. Okay, so you should see that 9 to the second power is equal to m, and you can start to see how you can solve for different variables. So 9 squared would be 81, and we solve for m. This question only asks to convert, so for this one you could stop right here. All right, let's use our new knowledge of the logarithmic notation and evaluate each expression. And what we'll be looking for is the power. So sometimes it's helpful to set these equal to a variable, but you don't have to. But this is what we're looking for, what power. So 2 to what power is equal to 16? So 2, you could also write it with the equation, the exponential equation. So 2 to what power is equal to 16? So if we think about 16, we know 16 is 8 times 2, and we know 8 is 2 cubed, so we could write that as 2 to the x is equal to 2 to the 4th, and we can see that x must be equal to 4, and then we can also check it. So our answer is 4, or x equals 4. Our second problem is even easier because we are very familiar with this. We say 12 to what power is equal to 144? And that's one of our perfect squares. So we know 12 to the second power is equal to 144. So that answer is 2. And if you wanted to write the equation, you'd say 12 to the x is equal to 144. And our answer is 2. All right, we're going to use these to solve some equations. Let's start off with number 1. And we're just going to write down the problem and convert to exponential to solve. So we have the base of 9 to the second power is equal to x, so x is equal to 81. For number 2, we have log base 1/7 a equals -1. So the first step, only way we're going to get to that variable is if we convert to exponential. So we have 1/7 to the -1 power is equal to a. Remember what a negative exponent is. Our first step is we're going to flip this fraction here, change it to the reciprocal, because this negative exponent would move the 7 up and the 1 down, and then would become a positive. So 7, 1 to the first is 7, so a is equal to 7. Alright, go ahead and pause the video and bring it back to check your answers for 3, 4, 5, and 6. Okay, for number 3, you should have converted to exponential as your first step. So 3 to the x power is equal to 27. And then we know that that would have to be 3. For number 4, remember you convert to exponential. So 8 to the 1/3 power is equal to n. Remember 1/3 would be have an index of 3, so the exponent over the index of 3. So 8, the cube root of 8, because 8 to the first to the third index, so the cube root of 8 would be equal to n, and n is 2. For number 5, you'd start just by converting to exponential, and we have 10 to the first power is equal to x squared plus 1. And then to solve for a quadratic, we have to move everything to one side and set equal to 0. So that subtracting 10 would leave us with x squared minus 9, which we can factor to x minus 3 and x plus 3. And we set those two factors equal to 0 using the zero product property and solve for x, and we get 3 and -3. For number 6, our first step was to convert, so 2 to the 6th power is equal to 3x minus 8, and then we just solve for x. We're just evaluating and solving for x, and we get x is 24. Alright, so our common logarithms, remember our log base 10, and we also, the log base e is used. Remember, log base e is the natural logarithm. And these common logarithms are in our calculator, and that's why they're used. They were established a long time ago to be used as our common logarithms, and we'll be learning more why that was so. The first thing I want you to try is to evaluate the log base 10, and in particular log 4. So you need to plug into your calculator log 4 and see if you can get 0.6021. Go ahead and try that and bring it back. Okay, so go ahead and try log 23 and log 1/2 and bring it back. So these are the values you should get. Now we're going to be using those common logarithms to solve equations, exponential equations now. Because remember, we could convert to the change of base formula and then solve. So let's first convert to the log base. So log base 3 of 11 is equal to x. And then we're going to use the change of base. So it would be log 11 divided by log 3 to find our x. Go ahead and try that and bring it back. Okay, and you should have got 2.1827. And that should make sense to you. 3 to the x power equals 11 should be some number between 2 and 3. The x should be and closer to 2. And then we would check it as well. And when you check it, it is right.